So the concept I want to go over is light and its interactions with matter, as well as the electromagnetic spectrum. Light is a form of energy. The energy that light carries is called radiative energy. Radiative, kinetic, and potential energy make up the three basic categories of energy. We measure energy in units of joules. Light always travels through space at the speed of light, and the rate of energy flow is called power, which we measure in units called watts. Light comes in different colors, or different forms that we call colors, and the basic colors are red, orange, yellow, green, blue, and violet, and white when all those colors are mixed in roughly equal proportions. Black is what we perceive when there is no light and hence no color. Light can interact with matter in four basic ways: emission, absorption, and transmission, and reflection and scattering. Emission, like kind of an example of that could be a light bulb emits light. The energy of the light comes from electrical potential energy supplied to the light bulb. Absorption is when you place your hand near like an incandescent light bulb and your hand absorbs some of the light, and this absorbed energy warms your hand. Transmission, some forms of matter, such as glass or air, transmit light, which means allowing it to pass through. And reflection/scattering, light can bounce off matter, leading to what we call reflection, when the bouncing is all in the same general direction, or scattering, when the bouncing is like a lot more random. Light is both a wave and a particle. A particle is like a thing, while a wave is a pattern revealed by its interactions with the particles. The three basic properties of waves include wavelength, frequency, and speed. Wavelength is the distance from one peak to the next. Frequency is the number of peaks passing by any point at each second. And speed is the speed of a wave tells us how fast their peaks travel. A field is used to describe the strength of force that a particle would experience at any point in space, and light waves are traveling vibrations of both electric and magnetic fields. So we say that light is an electromagnetic wave. We also say that light comes in individual pieces called photons that have properties of both particles and waves. And now talk a little bit about the electromagnetic spectrum. Along the electromagnetic spectrum includes many types of light, from highest energy / shortest wavelength to lowest energy / highest / longest wavelength. It goes gamma rays, X-rays, ultraviolet rays, infrared, and radio waves. The light we can see, visible light, is found near the middle of the spectrum, with wavelengths ranging from about 400 nanometers at the blue and violet end of the rainbow to about 700 nanometers at the red end. A nanometer is a billionth of a meter. Light with wavelengths somewhat longer than red light is called infrared because it lies beyond the red end of the rainbow, and radio waves would be also the longest wavelength of light. And then on the other side of the spectrum, light wavelengths somewhat shorter than those of blue light is called ultraviolet because it lies beyond the blue or violet end of the rainbow. Light with even shorter wavelengths is called X-rays, and the shortest wavelength of light is called gamma rays. What attracted me to the concept is the fact that without light, we would know very little about space. Light is what allows us to study space, and it's what has enabled us to learn what we've already learned about space. There are a few things that I felt were difficult about this concept, the first being the fact that this was like the first concept we really went over as a class. I'm a junior in college and haven't had to take a science class in a few years, so the information was pretty new to me. I also couldn't grasp the fact that light acts as a wave and a particle. It took me more reading and more studying to finally, understand that light is both a particle and a wave, which is an idea we describe by saying that light consists of individual photons characterized by wavelength, frequency, and energy. The concept of light and its interactions with matter impacts the course because light is the key source of information for observational astronomy. Without light, we would know very little about space and what occupies it. Light is arguably the most important factor in our ability to study astronomy. Light can be looked at as a measuring cup in regards to our ability to observe and study astronomy. Light, like the measuring cup, is what allows us to make measurements and observations in space. Without a measuring cup, we wouldn't be able to tell how much liquid we have, just as without light, we wouldn't be able to make any measurements or observations about space. We use the speed of light as a measurement a lot in astronomy, and without light and the measuring cup, it would be hard to gather any information on space and the liquid in the cup. And then, just to kind of finish it off, some improvements that I think would help enable the teacher to effectively communicate this concept to the class would be to remember that this is some students' first time to go over this material. So it's important to kind of start off slowly and completely make sure students understand the concept of light being a particle and a wave, and how light consists of individual protons and what individual photons and what exactly that means. Another thing I think would be helpful would be to stress the importance of light, as if like students start off understanding how important it is to grasp the concept of light. I think it would make them more apt to study the information and learn it better than they would not really understanding the importance of it. So yeah, and again, I just think concept of light and its interactions with matter is very important, and I think that's definitely one that should be stressed to students.